Welcome to the fascinating world of quantum computing, where the laws of physics meet frontline technology to revolutionize the way we process information. In this video, we'll dive deep into the realm of quantum mechanics and explore how it's being harnessed to create the most powerful computers ever conceived. Quantum computing is a groundbreaking field that leverages the principles of quantum mechanics to perform complex calculations at speeds unimaginable with classical computers. Unlike traditional computers that use bits to represent information as either 0 or 1, quantum computers use quantum bits, or qubits, which can exist in multiple states simultaneously. This fundamental difference allows quantum computers to process vast amounts of data and solve certain problems exponentially faster than even the most advanced supercomputers. Imagine being able to simulate complex molecular interactions for drug discovery, optimize global supply chains, or break unbreakable encryption codes, all in a matter of seconds. At the heart of quantum computing are three key principles: superposition, entanglement, and interference. Superposition is the ability of a qubit to exist in multiple states at once. While a classical bit is either 0 or 1, a qubit can be 0, 1, or any combination of both simultaneously. This property allows quantum computers to perform many calculations in parallel, dramatically increasing their processing power. Entanglement is a phenomenon where qubits become interconnected in such a way that the state of one qubit cannot be described independently of the others. This mysterious connection allows quantum computers to perform operations on multiple qubits simultaneously, enabling them to solve complex problems more efficiently. Quantum interference is the process by which the probabilities of different quantum states interact, either amplifying or canceling each other out. Clever quantum algorithms exploit this property to enhance the probability of measuring the correct answer while suppressing incorrect ones. There are several approaches to building quantum computers, each with its own advantages and challenges. Superconducting qubits, used by IBM and Google, these are currently the most advanced in terms of qubit count and performance. Trapped ions, employed by IonQ and Quantinuum, offering high fidelity but slower operation speeds. Silicon spin qubits, pursued by Intel and others, promising easier integration with existing semiconductor technology. Photonic qubits, developed by companies like PsiQuantum and Xanadu, using light particles for quantum operations. Topological qubits, a theoretical approach being explored by Microsoft, potentially offering more stable qubits. Quantum computing holds immense potential to revolutionize various industries, offering transformative applications across multiple fields. In drug discovery, these powerful machines could simulate intricate molecular interactions, dramatically speeding up the development of new medicines and treatments. The finance industry stands to benefit from quantum computing's ability to optimize investment portfolios and assess risks in real time, potentially reshaping financial strategies and decision-making processes. While quantum computers pose a threat to current encryption methods, they also pave the way for new, theoretically unbreakable quantum encryption techniques, reshaping the landscape of cybersecurity. In climate science, quantum computing could enable more accurate simulations, enhancing our understanding of climate change and aiding in the development of mitigation strategies. Furthermore, quantum machine learning algorithms have the potential to significantly boost AI capabilities, leading to groundbreaking advancements in pattern recognition and data analysis across various domains. IBM has been at the forefront of quantum computing research for years. In 2024, they unveiled their most powerful quantum processor yet, the Condor, boasting 1,121 superconducting qubits 9. IBM's quantum roadmap extends to 2033, with plans for a 100,000 qubit system and the development of error-corrected logical qubits. Google made headlines in 2019 with its claim of achieving quantum supremacy. In 2024, they introduced the Willow processor, featuring 105 qubits and incorporating enhanced error correction techniques. Google is collaborating with NVIDIA to simulate next-generation quantum processors using the NVIDIA Q2Q trademark platform. Microsoft has taken a unique approach with its focus on topological qubits. In 2024, they partnered with Atom Computing to launch their first commercially available quantum computer, boasting 24 entangled logical qubits, the largest number reported to date. IonQ uses trapped ion technology and has made significant strides in quantum computing. In 2024, they opened a dedicated quantum computing factory in Bothell, Washington, focusing on advancing their technology and scaling their quantum systems. Formed by the merger of Cambridge Quantum Computing and Honeywell Quantum Solutions, Quantinuum has developed the system model H1, which has been selected by RIKEN for a large-scale hybrid quantum supercomputing platform in Japan. The year 2024 marked a significant milestone in the realm of quantum computing, with remarkable advancements across various fronts. One of the most notable achievements was in the field of quantum error correction, where substantial progress brought us closer to the holy grail of fault-tolerant quantum computing. This breakthrough has the potential to dramatically improve the reliability and stability of quantum systems, paving the way for more complex and practical applications. Several companies made headlines by claiming to have achieved quantum supremacy for specific tasks, demonstrating the ability of quantum computers to outperform their classical counterparts in certain areas. While these achievements are still limited in scope, they represent a crucial step forward in proving the viability and potential of quantum technology. The integration of quantum processors with classical supercomputers has opened up new avenues for quantum-accelerated computing. This hybrid approach allows researchers to leverage the strengths of both quantum and classical systems, potentially leading to breakthroughs in fields such as drug discovery, financial modeling, and climate prediction. As we peer into the future of quantum computing beyond 2025, the landscape appears both thrilling and transformative. The coming years promise groundbreaking advancements that could reshape our technological world. Experts anticipate the emergence of quantum advantage, where quantum computers will demonstrate their ability to solve real-world problems faster than classical computers, marking a significant milestone in the field. The convergence of quantum computing and artificial intelligence is expected to accelerate, potentially catalyzing breakthroughs in both domains. This synergy could lead to unprecedented advancements in machine learning, data analysis, and problem-solving capabilities. Simultaneously, we're likely to witness increased industry adoption of quantum technologies, with sectors such as finance, pharmaceuticals, and materials science at the forefront of this quantum revolution. So, whether you're a scientist, an entrepreneur, or simply a curious observer, keep your eyes on the quantum horizon. The next few years promise to be an exhilarating journey into the quantum realm, and the discoveries we make along the way could change our world in ways we can scarcely imagine. And that's all for today. Remember to like, subscribe, and share this video to help others understand the exciting world of quantum technology. Until next time, stay curious and keep exploring the quantum frontier.